Hello everyone, welcome to the solution of LeetCode problem 110 named balanced binary tree. In this problem, we have to determine whether a binary tree is height balanced or not. So here, for the height balance, a height balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs more than 1. That means we can say that the depth of the two subtree of every node never greater than 1. And if it is, this tree is not height balanced, otherwise the given tree is height balanced. In the example 1, for this tree, it is height balanced because for the root 3, the left depth is 1 and the right subtree depth is 2. So here their difference is 1, so it is not greater than 1. But for the second subtree, the left subtree depth is 3 and the right subtree depth is 1. So their difference is 2, which is greater than 1. So it is not a height balanced tree. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to solve this problem, we will use the depth first search algorithm. So let's see how the DFS basically works here. This is our start root 1. So we will start the DFS from here. And we know that in the DFS, at first, we will recursively call the DFS function into the left subtree. After completing iteration in the left subtree, we will repetitively call it into the right subtree. Or we can say that this is a in-order traversal. Anyways, we are calling the DFS in the root node, and from here, we are calling the DFS function from the node 2. Again, we are calling the DFS function from the node 3. Again, we are calling the DFS function in the node 4. Now, for this node 4, its left and right subtree is null. So here, we will call the DFS function from the null and it will return 0. Because if the node 4 is the root, its left subtree depth is 0 and its right subtree depth is also 0. And it will return 1, which is the maximum of 1 plus 0 and 0. Now again, from this tree, we will call it here from 4 and it will again return 1 because it also does not have any of the left and right subtree. Both of them are null, so they will return 0 and this 4 will return 1. Now, as for this node 3 is left subtree and right subtree is traversed, so we will simply return from node 3. So what the node 3 will return? It will return 2, which is this root or this path plus this path. Or we can say it is the maximum of 1 plus 1 and 1, which is 2. Now again, we are at this node 2. And from this 2, we will call the DFS here. And it will again return 1, which is the maximum of 1 plus 0 and 0. Because its left and right subtree is null. So it will return basically 3, which is the 1 plus maximum of 2 and 1. This 2 and this 1. So it will return 3. Now again, we will recursively call the DFS here and it will return 1 as well. Now, for this root node 1, we have seen that its left subtree depth is 3 and its right subtree depth is 1. And their difference is 2, which is greater than 1. That means that violates the height balance theory. So here we can see that this tree is not height balanced. And this is how we're going to solve this problem by using the recursive DFS function. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function name is balanced, which has an input root or input tree as a parameter. Now we are taking a global variable is height balance. Initially, it is true. Now we are calling the DFS function with this root. So here inside the DFS function, if the root is null, we have to return 0. Otherwise, we have to simply store the DFS call from the root left and the root of right. Or we have to recursively call the DFS in the left subtree or the right subtree and store the value into a left and right variable. Now here, if in any of the root, the left and right is greater than 1, basically their difference greater than 1, that means this is not the height balance. So its height balance will be initialized with false. Otherwise, for each of the iteration or each of the subtree, we have to simply return its depth, which is the 1 plus maximum of left subtree height plus right subtree height. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.